Let's have a look at the fifth index law, okay, also called the negative index law. And the rule states that a negative index represents a fraction or a reciprocal. Reciprocal means that you're turning something upside down. So take, for example, 2 to the power of negative 3. Okay. The negative here just means to express this as a fraction with a positive index. So 2 to the power of negative 3 can be written as a fraction, and the fraction is 1 over 2 to the power of 3. And 2 to the power of 3 we know is just 8. 2 times 2 times 2. Okay, so just remember when you see a negative index, okay, so an index with a negative sign there, it just means that this entire term is to be written in fraction form. Now, we've just got to be careful with that. There's one example we'll look at where you've just got to be mindful as to what is in the denominator and what is in the numerator though. Okay, so let's have a look at some examples. So we're going to express using positive indices. There's actually 5 examples. E's on the other side of the board. X to the power of negative 2. Okay, the negative here next to the index just means that it's a fraction. Okay, and it's a fraction 1 over x squared. So notice how the negative power, the negative index, has become a positive index. Okay, let's have a look at the next one. 3a to the power of negative 4. Now notice that the negative 4 is applied to the entire bracket. Okay, so that's why we have brackets. That's why it's called a grouping symbol. 3a, okay, is going to be in the denominator. Okay, because of the bracket and because of the negative 4. So this is really 1 over bracket 3a to the 4. Okay, and we can then apply the power to a power rule, and that's just 1 over, you got 3 to the power of 4 is 81, and a to the power of 4 is a to the power of 4. Nothing we can do with that really. Part C, 3a to the negative 4. Notice the difference between part B and part C. Okay, there's no brackets here. So this, okay, is an example of what I was talking about before, where you've got to be careful with what's on the numerator now. Okay, this is the expression, or expanding this expression, this is just the expression 3 times a to the negative 4. The 3, well, that's just 3 over 1. Okay, and a to the negative 4, that's just 1 over a to the 4. And multiplying the two fractions together, we get 3 times 1 is 3 over 1 times a to the 4, which is just a to the 4. So notice that the solution to part C is 3 over a to the 4, not 1. Whereby with part B, it's 1 over 81 a to the 4 because of the brackets. Okay, it just means that the brackets, the entire bracket ends up in the denominator. Okay, and the last one, a, b squared, c to the negative 3, d to the negative 4. So I just put that one in for a bit of fun. We have a mix of positive and negative indices. Okay, that's just a to the 1. Okay, but there's no negative index there, so the ab squared is actually in the numerator. But then you've got c to the negative 3, d to the negative 4. That means that c and d are in the denominator, the bottom part of the fraction. So that's going to be c cubed d to the 4. Okay, so that's just a nice easy way to look at it. Anytime you have a positive index is the numerator, negative index, denominator. Okay, that's the general rule. Of course, there are some strange expressions where you know it might be a bit more complicated than that, but for most general expressions using negative indices, it just means fraction. Okay, but you just got to be careful what goes where. Let's have a look at part E. Okay, which is 2 to the power of negative 1 to the power of negative 1. Now, that's another interesting one. And we'll sort of look at how this all works shortly, why this works. 2 to the negative 1 to the power of negative 1. Another way to look at it is 2 to the negative 1 just means take the reciprocal of it. Okay? So 2 to the power of negative 1 means the reciprocal of 2. The reciprocal of 2 is just 1 over 2. And that's to the power of negative 1. Now, raising half to the power of negative 1 means take the reciprocal again. So that's just 2 over 1. Okay? And so the answer is 2. Okay, so anytime you're raising something to the power of -1, -1 actually means reciprocal. Okay, so it means just basically flip it. Okay, turn the fraction upside down. Now, how else could we know, or how else do we know that this works and we end up getting 2 as an answer? Okay, remember index law number 3, okay, the power to a power. So if you multiply those two powers together, okay, so this is really sort of another way to look at it, okay, that's just 2 to the power of -1 times -1, okay, and -1 times -1 is just +1, and that's just 2. Now, last question: where does the negative index law come from? Okay, and we'll look at a particular example, say maybe one example using numbers instead of pronumerals. Let's say, for example, we had 2 to the power of 0 divided by, say, 2 to the power of 3. Let's say that for argument's sake as an example. How does this work? Now, bases are the same. Okay, you have a division, so you're dividing bases that are identical. What happens to the indices? Okay, you subtract the indices, don't you? Right. So that is just 2 to the power of 0 minus 3, and that is just equal to 2 to the minus 3, or 2 to the -3. Right, but we know what 2 to the power of 0 is, don't we? Remember the rule, index law number 4, the 0 index law? Okay, the 0 index law states that anything raised to the power of 0, as long as the base itself is not 0, anything raised to the power of 0 is 1. Okay, and 1 divided by 2 to the power of 3 is really the same as saying a fraction, or writing it as a fraction, 1 over 2 to the 3. Okay, which is also the same as 2 to the -3. Okay, so there's actually, like I said, 2 ways of looking at it. This is index law number 2, then we looked at index law number 4 and applied index law number 2 again, and 1 divided by something means it's just a fraction with a 1 on top. Okay, so if you remember how division works, the first number is the numerator, the second number is the denominator, and that's also equal to 2 to the -3. Okay, so 2 to the -3 is the same as 1 over 2 to the 3. Okay.